Welcome back once again. So we're still on our 5-number summary. We have looked at the lower quartile, the second quartile, which is the same as the median, very important, which is Q2, and the upper quartile, which is Q3, or known as the upper quartile. What about the last two? So we said 5-number summary, so we need 5. Okay, let's look at the last two. So we have what is known as the minimum value. So this is the first number once the data has been written in order from the smallest to the highest, therefore that's the minimum. Okay. Then our last 5-number summary is called the maximum value, and this is the last number once the data has been ordered from the smallest to the highest. Okay, so let's look at this 5-number summary. I'm going to try and draw this for you. So it implies we have a minimum, min for minimum, then we have maximum there, then we'll have Q1, which is lower quartile, we'll have Q2, we'll have Q3, which is the upper quartile. And if you look at this, from minimum to Q1 is 25% of data. From Q1 to Q2 is 25%. From Q2 to Q3, another 25%. And Q3 to maximum, another 25%. What does the 5-number series do? Divides the set of data into quarters, or 25. But what is interesting, look, between Q1 and Q3 is 50% of the data. Okay, between Q1 and Q3, okay? Remember, we might have extreme values. I mean, I might want to say, you know what, I'm going to focus from Q3 to Q1, which is the middle of the data. Because think about this, if I have to calculate a range using the smallest minus the minimum, it might not really give the sense how the data is distributed. But what if I focus in the middle? I might get a sense of what is happening in the middle or how the data is distributed. Okay, fantastic, guys. This is our 5-number summary. Okay, so what are you going to do? Now we have an example here. So the ordered age of 12 brides marrying at registry office in the same month in 2015 were 21, 24, 21, 24, 25, 25, 27, 28, 31, 34, 37, 47, that. Okay. So what we want to do is to find the 5-number summary. The data has already been ordered for us. We can tell the minimum value, which is 21, the maximum value, which is 61. Okay. So let's look at this. So, okay, so what we have here, we have 12 brides marrying at the registry office. So we're given the months. Okay, so this is the data. The minimum is 21. The maximum is 61. We have to find our 5-number summary. So let's see. So what you're going to do is start with the median, okay, which is Q2. And how do we find the median? The median is the middle one, okay? So you can arrange your data from the smallest to the highest and find the middle number. Or what you can do, you find the position of the median. So the position of the median, which will be a half. What is the data set? This is 12. 12 plus 1 is 13. 13 divided by 2, it will give us 6.5. Okay. Then you count 6.5. This is 1, 2, 3, 4, 5, 6. 6.5 is between 28 and 31. This is how we got the 29.5, so which is 28 plus 31 divided by 2, it should give you 29.5. So 29.5 is our median. We just used a half n plus 1 to find the position. You don't have to do that because you have a small set of data, you can find the middle, okay? Because if you have 12, the middle is about 6.5. Okay, does that make sense? Because you have 6 this side, 6 that side, the middle is just after 6. So our lower quartile is 29.5. Then Q1, we can find it there. Okay, where I've highlighted. So it's between 25 and 25, which is actually, because this is the median from there to there. So it's 25 plus 25 divided by 2 by just looking. Or you can go, okay, quarter. What is data size? 12 plus 1, which is 13. 13 divided by 4 will give us 3.5. Then you find position 3.5 is there. It's between 25 and 25. Then what do? You say 25 plus 25 divided by 2, which will give us 25, which is our lower quartile, or Q1. What about the upper quartile? We have to use the last 50% of the data to find the median of the last 50%. Okay, does that make sense? You can do it by inspection, by just looking at data and say, okay, there's the upper quartile. Or you can use the formula 3 over 2 n plus 1. Okay. So what do you do there? You can say 3 over 4 n plus 1. If you do that, where n is 12, you should be getting, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. You should be getting actually 9.5. So 9.5 from here, it's a position, just indicates position. Go to position 9.5 and find the upper quartile or the Q3. Then what do? It's 37 plus 43 divided by 2. That will give us 40, which is our upper quartile. Okay. Are we fine? So Q1, Q2, Q3, those are our quartiles. Okay. Then we can find the minimum value and the maximum value. We know that the minimum value is 21 and the maximum value is 61, which is the highest. We have our 5-number summary. So it's better to have this than having a raw data, you know. I can do some analysis with 5-number summary. Okay. So what are we going to look at now? We've looked at 5-number summary, which is our quartiles with the minimum value and the maximum value. We'll still look at something called the interquartile range. So the range also, then the box and whisker. We need the 5-number summary to draw something called the box and whisker. And we know what are quartiles now, okay? And there's also an interquartile range. So this are called the measure of the dispersion below, and the measure of central tendency, okay, which is mean, median, and mode. There are more. So let's look at the box and whisker plot. So the box and whisker plot is another way of representing data, but representing data using the 5-number summary only. Okay. You don't want to write a report with 10,000 of data. You want to write a report, right, giving 5-number summary. Okay. That's what we need, okay, to do some analysis. Giving me 100 data set doesn't mean anything, okay, unless you analyze that or represent the data. So let's look at the box and whisker. So we say it's a graphic representation of 5-number summary. which is the minimum value, our lower quartile, and median, which is known as Q2, and also as the upper quartile, which is Q3, and our maximum value. Okay. Are we all together? So we're talking about the Whisker plot, which we're going to draw it now. To draw the Whisker plot, we need what? The 5-number summary to draw that. Let's look at that. So the box plot or the Whisker plot is useful when comparing two or more sets of data. What does it mean? I might want to compare male and female. How do they perform academically? So I need two sets of data, how females are performing in schools or male, then have two Whisker plots for that. So it's very useful if you have two sets of data to compare what is really happening. Okay. So guys, after the break, we'll draw a Whisker plot using our 5-number summary and see what it looks like, okay? I hope to see you again after the break with the Whisker plot. Great.